All right, I'm going to take you through homework 5 right now. So problem number 1, we've got credit score measures a person's creditworthiness. Assume the average credit score for Americans is 709. Assume the scores are normally distributed with a standard deviation of 55. So what they're telling us is that the mean is 709 and the standard deviation is 55. So we're looking for an interval here between the mean and one standard deviation away from it. So we need two parts here. We need the mean minus the standard deviation, which is 709 minus 55, and that comes out to 654. And then we need the mean plus that standard deviation, and that's 764. So our interval is 654 to 764. Part B is the same thing, only we're going to do two standard deviations. So the mean plus 2 sigma. So we're looking at 2 times 55, and that comes out to 819. And the mean minus 2 sigma. And that comes out to 599. So we're going from 599 to 819, and that's it. All right. Assume the random variable x is normally distributed. So we're given some information. We're given that it's normally distributed. We have a mean of 50, standard deviation of 7, and I've given both the words and the symbols there. And then this next bit, for the following, list the calculator function and the inputs as well. So in order to do this problem, you have to make sure that you're writing down the calculator function that you use, and I've got a calculator up right here. So we want the probability that x is between 57 and 69. Well, we're going to use a Normalcdf. Our low value is 57. Our high value is 69. Our mean is given as 50. And our standard deviation is 7. So let's put that into the calculator. That's second, and then the vars key to get you here. And then the Normalcdf is number 2. We never use that top one, but we're going to use a Normalcdf for this one. So 57, the comma is above the 7. 69, another comma, 50, another comma, and 7. Now, your calculator may just ask for high, low, mean, and standard deviation. And then when you give it to them, it'll hit, when you hit enter, it'll show this to you, so you at least have what it's looking like now. Let's hit enter and see what we have. So this is a normal distribution probability, which means it needs to be rounded to 4 decimal places. Not 4 sig figs, but 4 decimal places. So 0.155, and then that 3 after it's another 3, so 3. 4 decimal places for these. You contribute less on your exam, you're likely to lose some points. B, probably between 45 and 68, very similar. So 45 is low, 68 is the high, and again 50 and 7 are our mean and standard deviation respectively. Second vars, Normalcdf, because we're looking for a probability, looking for an area. So 45, comma, 68, comma, 50, comma, and 7. And if they give you the questions where you're entering them in the display, you don't need to put the commas in there. That'll do it for you afterwards. This one is 0.7574 when rounded to 4 decimal places. All right, less than 72 or less than or equal to 72 is actually the same question. So Normalcdf, we're not given our low, so we're going to use this some very, very, very large negative number. The biggest one we can find is negative 10 to the 99th power, or negative e to the 99. You can get away with putting in something like negative a million in there, or something like that. That'll work. But it's just easier, so you don't have to worry about how many standard deviations you are away, to just throw in negative E99. And I'll show you to do that in a calculator in a second. Our high value is 72, then 50, and then 7. So second vars. So the negative key you want to give it is not the minus key, but this little dash, which is lower left of enter. Oh, I need, first of all, to grab the Normalcdf. So negative, the e we're going to use is the second function comma. So second comma gives us that e. That's a little different than Euler's e, although Euler's e would work fine in this case. But we're using this e as a standard one. This is a standard base 10 to the 99th power, comma, 72, comma, 50, comma, 7. And that gives us to 4 decimal places 0.9992, because the 6 after the 1 is 5 or greater. 9992. The probability that we're greater than 55. Normalcdf, 55 is our low. Positive E99, positive infinity is our high. I'm not going to use the calculator. I'm just going to write down the answer to this. We'll do the calculator for this 85th percentile. So now we're given an area. The 85th percentile means that this is 0.85, and this is our x. So this is the inverse norm. Our area to the left is 0.85, and you may have a calculator that will ask left, right, or even middle. That's possible, but the basic way to do it is to give it the left, and then you tell it the mean and standard deviation. And we'll do that in the calculator. Inverse norm is the third option. Second vars, inverse norm, 0.85. Don't tell it 85, that'll be a mess. Comma 50, comma 7. So 57, 57.3 or 57.26. I'm going to go with 57.26. 57.3 is a fine answer. You probably should not answer 57, though. Usually try to give it a couple sig figs after the decimal. So that's the normal distribution. This next question only deals with the uniform distribution. Uniform. Okay? Which means we're not going to use the normal distribution at all. We're going to use what we learned about the uniform distribution for this. So the heights, well, the height is just sort of f of x, and that's 1 over d minus c, which is 1 over our d is 120, our c is 30, so that's 1 over 90. And you can calculate the decimal for that if you want, that's fine. Draw the distribution. All right, well, we've got an f of x over here and an x over here. You need to label both. And since we seem to be going up by 30, we'll do that. And then the height is 1 over 90. And the x-axis and y-axis do not have to be to the same scale. This wouldn't make any, we couldn't see anything if it was. So our line here, let's just kind of change the color here. And that's a little off from my 190, so let's try that again. 1 over 90. So. All right, so that looks to be pretty good. So that's our distribution. It doesn't exist below 30, and it doesn't exist above 120. Okay, now we want the probability that the task will take between 60 and 90 minutes. So we're looking for probability that, well, let's Let's write it correctly here. 60 is less than x is less than 90, and you can use less than or equal to's instead of less than's. It doesn't matter for this formula. So from our formula for uniform, that is going to be 90 minus 60. That's the area of the bottom. That's over our f of x, which is, or times f of x, which is 1 over 90, or just divide d minus c, which is 90. So that gives us 30 over 90, or just 1/3. And I left it like just 1/3. You want to make it 0.333, that's fine. Calculate the probability the task will take 45 minutes. So we're looking for the probability that x equals 45, which is the same as the probability that 45 is less than x is less than 45. Well, I think you can see where we're going with this. 45 minus 45 over 90 is just 0 over 90, which is just 0. And in fact, anytime we take the probability that x equals a given value for any value in a uniform distribution, a normal distribution, or any other continuous distribution, it will always be 0. And finally, we want the mean and standard deviation. So the mean, we'll just use the symbol for mean. That equals 120 plus 30 over 2. That's our D and C added together divided by 2. And that comes out to 75 because then we get 150 on top. The standard deviation is less intuitive. It's that D minus C over root 12. So 120 minus 30 over root 12, not 10. Which equals 25.98 when we put it in the calculator. So this is homework 5. And again, remember some of the things that I did. Normalcdf and inverse norm, use the calculator functions for those. Put down your work on those. And probabilities for normal are 4 decimal places, not just round responsibly.